Alright, so this is the remainder theorem in polynomials. So we're basically solving for an unknown using they've given us what the polynomial is being divided by and the remainder. So we use this information to find a. And this is using the remainder theorem. Okay. So first we would start with so we want to define this polynomial as a function. So we can just say let f of x equal x squared plus 5x plus a. Right? And the remainder theorem states, well, okay, one more thing I need to add. In the remainder theorem, look at your second term here in your thing. You look at your second term, which is this positive 1, and you want to flip the sign of it and make it negative 1. And you input that right here. So f of negative 1, right? And the remainder theorem states that, in this case, f of negative 1 equals our remainder, which is negative 6. Okay, so now f of negative 1 just means that wherever there's an x in this function, we replace that with negative 1. All right, and we know that it's equal to 6, so we can solve for a given this. Okay, so we've got, I'll just set minus 6 on the left side, makes it easier. Negative 1 squared plus 5 times negative 1 plus a. Negative 6 equals negative 1 squared is just 1. 5 times negative 1 is negative 5, so minus 5 plus a. So this is just negative 4, while minus 5 is negative 4. Add 4 to both sides, you get a is equal to negative 2. So that's a. That's basically just it, I guess. All right. We can try b. Okay, b. I'll probably just move this somewhere. Put it over there. All right, b. All right. Let f of x equal. Let f of x equal negative 2x squared plus ax plus 8. Right. Now, using the remainder theorem, remember we swap the sign of our second term. Our second term is negative 3, so swapping the sign makes it positive 3. So we put in here f of 3, and our remainder is 2. So f of 3 equals 2. All right. I'll just put the 2 on the left-hand side. 2 is equal to, all right, negative 2 times 3 squared plus a times 3 plus 8. Right, using order of operations, you'd work with the indices first. So that would be negative 2 times 3 squared. 3 squared is 9. Negative 2 times 9 is negative 18. Plus 3a, because a times 3 is 3a, plus 8. All right, collect like terms. So negative 18 plus 8 is negative 10, plus 3a. Now, we add 10 to both sides to get rid of this negative 10. 12 is equal to 3a. So a is equal to 12 on 3, which is just 4. So a is equal to 4. All right. Now we can try C. Same thing, except the degree of the polynomial is 3 this time, meaning that there's a 3. The highest degree is 3. Okay. So for C, C, what we do is we define the function first. So let f of x equal x cubed plus ax squared plus 3x minus 1. And using remainder theorem, we use the opposite of this sign, like the opposite sign of this number as our input. Just f of negative 4, and is a remainder of 3. Okay. Now, using this, we know that 3 equals, we substitute negative 4 in every x. So negative 4 cubed plus a negative 4 squared plus 3 times negative 4 minus 1. So this is just negative 64 plus 16a. And okay, 3 times negative 4 is negative 12. Minus 1 is negative 13. So I'll just say negative 13. Let's collect like terms. So 3 equals negative 77 plus 16a. Add 77 both sides. So we get 80 is equal to 16a. Right? And then we get a is equal to 80 over 16, which is equal to 5. So therefore a is equal to 5 in this remainder theorem.